Okay, so yeah, so I don't know, where did you lose me? Um, so we have this equation. Well, we have these equations and we wanted to write them in a matrix form. So what's the matrix form? You're gonna have a vector of constants, which is over here. I'm calling it B. Then a vector of variables, which is here, and the matrix of coefficients multiplying this vector of variables. Symbolically, I can write it like this, and that's just a compact notation for these linear equations. Now, the idea is that when this vector, this matrix will multiply this vector, it will give me back these equations. That's how I defined the matrix product. This was the whole idea of the matrix multiplying a vector. And how do I multiply a matrix with a vector? There were two ways. One was that you think of this matrix itself as composed of some row vectors. Row vectors, you can recall, so this is a row vector. If you just, instead of listing the numbers in a column, if you list them in a line from left to right, that's a row vector. And I denote it without a spike on the arrow, just a bar. So this matrix has 3 row vectors in it, which I have written over here. So if I write something like this, that's a matrix, a collection of rows. This particular matrix has these 3 rows. And how do I multiply this? I take each row and make its dot product with this vector with which I'm multiplying it. So when I take the dot product, I get 1 dotted with x1 plus 1 multiplied with x2 plus 0 multiplied with x3. Similarly, 2 with x1 plus 1 with x2 plus 1 with x3, and then 3 with x1 minus 1 with x2 plus 2 with x3. This is the result. And this is not a matrix. This is a vector. On this side, I had 5, 6, and minus 3. This is a vector because it has, it's just a collection of objects arranged in a column. So it has only one column. A matrix, what you call, well, you can even call this thing a matrix, saying that this matrix has only one column, but a matrix with one column is called a vector, a column vector. So it has only one column because this is one object. This is one object. And since these two vectors are equal, this is what the equality sign means, that the components, corresponding components are equal. So that means I must have the components equal. This equality of components finally gives me back my original equations. So no magic went in there, it's just that I have defined things this way. I have just defined the product of matrix with a column vector in such a way so that I can write this compact notation. So that when I multiply with my given definition, I get these equations. So it's the splitting open of this equation. Now let's do an example of matrix multiplication. So let me see. So I have one of this matrix, and then I have and we also have to decide if we can even multiply them, because we cannot multiply all matrices with each other. So like if I take these and call it A, call this B, and I'm trying to find A times B. So I can think of this, we learned two of these ways. Take these, consider this as composed of rows, but consider this guy as composed of vectors. And then you just think like I'm taking this vector and multiplying it with this matrix. I just told you how you do that. You take the dot product of this vector with each of the rows. So can I do that? I can do that because I have three components in these rows and three components in these columns. Three components in the rows of A and three components in the columns of B. The components have to be equal if you want to make dot product of a row and a column. So it can be done over here, and you get 3 times 2, that's the dot product multiplication of corresponding components in the same order. So that gives you the first element, and you just get a column back. But the size of the column has changed because you get the column back as much as you get as many rows back as you had in the A. So minus 2.2 plus 0.1 plus 2.1. So this is your first column. And now you just take the other column and do the same procedure. 3.1 plus 5.3 plus 1.1 minus 2.1 plus 0.3 plus 2.1. So if I write it symbolically, this is V1. Should I call it V1? Let me call it, okay, V1 is fine. V2. So A I'm writing as 2 row vectors, while B I'm writing as 2 column vectors. A1, A2, where A1 is just this column, the first column, and so on. Let me write one example of the V's. This is the first row vector in A. So this is the product, and the rule is that I take the columns of this, column vectors of this, and start making dot with each of these. V2, this is this has a spike. And then I take the second vector and start making the dots. That's what has happened over here. And if you want, you can even write the answer. 6 plus 4, 10, plus 5, 15. 15 plus 3, 18 plus 1, 19. I'm extremely bad in multiplying and adding numbers. This is minus 4 plus 2. So minus 2. And this is minus 2 plus 2. So 0. But these same matrices we can multiply. Yeah.
Sir, shouldn't the second row first entry be 4 plus 4? You're multiplying 2 by 4, right?
Which one? Where? Oh, yeah, this one is. No. You're taking this.
Third one. You're multiplying positive 2 with 4, right?
2 with 4. 2 with 4. Yeah, this is. So 3 with 2, 5 with 1, 1 with 4. Then minus 2 with 2, 0 with 1, and 2 with 4. So I looked at the wrong place when I was writing it. 2 with 4. So that gives me 8 minus 4. So this gives me a 4. Yeah, the rest is fine. Now, I'm going to think of these because I had another way of multiplying a matrix with some vectors. So this time, I even think of A as composed of some column vectors. So there are 3 of them. So the first column is this one, this is the second column, and this is the third column. Now I know that if I am given a matrix, how to multiply it with a vector. So again, I'm going to take this matrix and start multiplying with vectors one by one. If I think of this matrix as composed of vectors, then what I need is I need to make linear combination with the components which are lying in this vector. So here you had A1 and A2. This time I do not make a dot product. I take the components over here and make these linear combinations. 2 times W1 plus 1 times W2 plus 4 times W3. And this gives me one column over here. And then I do it with the second vector. So the second vector has components 1, 3, and 1. So I make 1 times W1 plus 3 times W2 plus 1 times W3. And then I just compute this linear combination. So you make linear combinations of columns in A with components in A1, A2, and so on. So if I do that, I just have to make this linear combination. I can as well write the W1's 3 minus 2, 5, 0. W1 is 3 minus 2. W2 is 5, 0. And W3 is 1, 2. So when I make these linear combinations, let me do it one by one just to make it clear. So 2 times W1, when you multiply a vector by a number, you just multiply each component with that number. So 6 minus 4 plus 5, 0 plus 4, 8. And over here, you have 6, not 6, sorry. W1 this time is just sitting alone. 3 minus 2 plus 15, 0 plus 1, 2. So then you add these. So 15 and 8. This was plus 4. 15 and 8. And in the second column, you get 19.
It's positive 15 and positive.
Positive
15 and 4 नहीं होगा.
Sorry. See, my problem is that I'm only used to of dealing with symbols, not with numbers. So you get this, and these are just the vectors in your new matrix which you have got. So I can even call them, give them some name. And you can remove these parentheses when you are writing the matrix in your usual notation. So this matrix is just a matrix of these two vectors. So you got the same answer because it's the same procedure, just looked in two different ways. In one way, you take these row vectors and each time you take a dot product with this vector and then the next vector. While in this way of thinking, you take the column vectors and each time you multiply with a vector in B by making linear combinations. So let me just purely do, well, let me do an example of, let me ask you this. So what if we compute B times A? One, 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 three, four, one. Four, one. and A was 351 minus 202. So how will I multiply it? If I use the first method, I have these columns in B, which I had been calling them A's. So I have these columns A1 and A2. And in this, I was calling these columns as W1. So my first method tells me.
So could you go to where you identified matrices A and B? Upar.
Yeah.
Sir, while copying them down, haven't you written them गलत? क्योंकि 214131 है. नीचे आपने थोड़ा different लिखा है.
211341 211341 यही लिखा हुआ 2.
सर आप नीचे सर when you're writing BNA आपने 14 लिखा हुआ है and 131.
कहाँ पे?
सर अब आपने 2 कर दिया है blue से.
अब कर दिया ना?
हाँ.
अब हो गया ना?
Thank you sir. हाँ सर.
So I'm doing the first method, so I don't need the column in this. In this, I need the row vectors. कोई भी इनको new नाम दे देते हैं. Let's call them S1, S2 without a spike, and S3. So पहला लेना है और इसके साथ डॉट प्रोडक्ट्स बनानी शुरू कर देनी है. So पहला कॉलम ये आएगा S1 dot W1, S2 dotted with W1 with same. जहाँ से first column में वही आएंगे जो dotted have with first column. So you take all the rows, take the dot with the first column, that gives you the first column. Again, take all the row vectors, dot with the second column, and you get the second column. So let's see, ये बाद में लिखेंगे, let's see what these dots are. I have a problem because S1, well, I don't have a problem, I can do it very easily. And the other ones are S1 dot W2, S2 dot W2, S3 dot with W2, and then S1 dotted with W3, S2 dotted with W3, and S3 dotted with W3. So S1 है 2 1 और ये इसके साथ डॉट लेना है, फिर 1 3 का इसके साथ लेना है, 4 1 का लेना है. Should I do it or should I just leave it over here? Let's just do it for once. Two into 3 and 1 into minus 2. Then 1 into 3, 3 into minus 2. Then 4 into 3 and 1 into minus 2. Then this guy has 5 0, so 2 into 5 plus 0 into 1, 1 into 0. Then 1 into 5 plus 3 into 0. Then 4 into 5 plus 1 into 0. The last vector has 1, 2. So 2 into 1 plus 1 into 2. 2 into 1 into 1 minus वो सॉरी प्लस है ठीक है प्लस 1 into 1 plus 3 into 2 and 4 into 1 plus 1 into 2. So I get a 4, 10, 2 plus 2, 4. I should have been writing the columns first. Minus 3, 10, 8, 20, 7, and 6. Similarly, you can do the other way around. Let me just do one last simplest example. You have one, 1, 3, 2, 1, 1, 0. And I have a vector and I want to multiply this matrix with this vector using the second method, thinking of them as columns. These columns. So what's the instruction? You take these components and start making, and just make the linear combinations. So you're just making this linear combination. And you get 6 plus 2 plus 1, 7 plus 6 plus 1, and 1 plus 2. So you get a 9.
That is 1 plus 4. 1 plus 4.
1 plus 4. 5. Yeah, so that's the idea. The other way of doing it was just to hammer it completely, that I make the, I think of which color should I use? This one. I take row vectors and take the dots with this. So the first dot is 6 into 1 plus 1 into 2 plus 1 into 1, which is exactly this. The second dot, this guy going into this. 7 into 1, 3 into 2, 1 into 1. and 1 into 1, 2 into 2, plus 0 into 1, which is exactly this. So I think with these examples, everything should be clear now, and we are ready for Tuesday's lecture. Okay, so see you on Tuesday.
Thank you, sir.
No, please.